Hello students, I am Suman. Today we will discuss the class 9 physics second lesson, force and law of motion. Previous day we haven't seen the Newton's law of motion. In Newton's law of motion, Newton's first law of motion, and the Newton's first law of motion is known as also the law of inertia. So there are two kinds of inertia. First is inertia of rest and second is inertia of motion. So here we will see some examples of inertia of motion. Suppose that you have a feel when a moving bus, when a running bus stops suddenly, the passenger inside the bus moves forward. Why? The passenger moves forward in moving bus as it stops suddenly. This is due to the inertia of motion. In this case, in inertia of motion, as the bus stopped, so the body of our body, which is contact to the bus, stops suddenly. But our upper part of the body is remain in motion due to inertia of motion. That's why the passenger moves forward. So this is examples of inertia of motion. Now today we will discuss the next law of motions, which is given by Newton's. It is Newton's second law of motion. Newton's second law of motion. What is Newton's second law of motion? In Newton's second law of motion, he stated that the rate of change of momentum is directly proportional to force applied on the object. Previous day we have been also shows about momentum, and we have been studied about momentum equal to product of mass and velocity. Product of mass and velocity. The product of mass and velocity of the object is known as the momentum, and we denote simply momentum equal to P. The mass is m and velocity is v. So P equal to m into v. So the momentum of the object is depend here on two factors. One is mass and other is velocity. And the SI unit of momentum, the unit of mass is kg and the unit of velocity is meter per second. So the SI unit of momentum is kg meter per second. This is the SI unit of momentum. Now here we'll see you will see an expression which is related to force and momentum, and we will find out the expression of force with the help of Newton's second law of motion. Newton's second law of motion told that the rate of change of momentum is directly proportional to the force applied. It means rate of change of momentum, force is directly proportional to change in momentum by time, and force we denote F. Proportional to change in momentum, here we will take delta P by delta T, because the object is in motion and the delta P is the short momentum and small momentum, and delta T is very short interval of time. So the change of momentum of the object for very short interval of time, F is proportional to, in delta P, in place of delta P we can write M into V by delta T. Here mass is constant. F is proportional to M delta V by delta T. Mass is constant. An object which is in motion, the mass remain constant, and the other quantity which is velocity will change. So in place change in velocity, suppose that an object whose initial velocity of the object is u and final velocity is v, then change delta v means change in velocity. Then we can write f is directly proportional to m, in place of delta v minus u by delta t, and f is directly proportional to delta v minus u upon t, and this is a value of acceleration, rate of change in velocity. So in place of u minus v upon delta t we can write a, and if you remove this proportionality sign, proportionality sign, so we will put k and a. In SI system the value of k is 1, or if we applied 1 Newton force on the object whose mass is 1 kg and it's produce an acceleration 1 meter per second square, then the value where k equal to constant and the value of k equal to 1 in SI system. The value of k is 1 in SI system, then we can write f equal to ma. This is the required expression for force. Then we can say force equal to mass and acceleration, and force is depend on the two quantities, it is mass and other is acceleration. If mass of the object will increase, the force also increase, and acceleration increase, force also increase. And the SI unit of force is Newton. It is denoted by N. And other unit of force is dyne, and this dyne is a unit of force in serious system. Dyne is a unit of force in serious system, and there is a relation between Newton and dyne. What is relation between? Here we will see the relationship between Newton and dyne. Newton and dyne. 1 Newton equal to when we will express this Newton, 1 kg into 1 meter per second square. 1 kg will convert kg into gram, it will be 1000 gram into 100 meter. So 100 meter will change into centimeter, so 1 meter equal to 100 centimeter by second square. 1000 into 100, so 10 raised to the power 5 gram centimeter per second square, and this value gram centimeter per second square is known as dyne. So 10 raised to the power 5, 10 raised to the power 5 dyne. So 1 Newton equal to 10 raised to the power 5 dyne. This is a required relation between Newton and dyne, and this is Newton's second law of motion. Next day we will see the Newton's third law of motion and some examples of Newton's second law of motion. Till then, thank you.